Welcome to Globe Goes to Camp, developed for the Global Learning and Observations to Benefit the Environment program by the Globe team at NASA's Langley Research Center. We're excited to have you participate with us and learn more about the trees around you and contribute data to support students and scientists around the world. Hi, my name is Brian Campbell. I'm a senior earth science specialist and Globe Observer Tree Science Lead with GST Incorporated at the NASA Wallops Flight Facility in Wallops Island, Virginia, USA. Prior to coming to NASA as a federal contractor in 2001, I was a high school earth science teacher and a NASA science teacher ambassador. I have always loved learning and teaching earth science. Coming to NASA, I am surrounded by cutting-edge earth science and data. I love that I have the chance to bring NASA science to you. Trees are shaped by the environment they grow in and events that occur during a tree's life. Like our fingerprints, every tree is unique. Even trees of the same species grow in different ways, at different speeds, and provide habitats to different animals. While each camp program will be implemented differently, a major component of Globe Trees is to practice identifying and measuring trees. By participating in these activities, you will learn how NASA studies trees from space, what affects a tree's growth and health, how trees fit into an ecosystem, and what animals call trees home. Measuring living things, such as the height of trees or shrubs, can add valuable information to land cover data needed for planning or research. For example, tree height is the most widely used indicator of an ecosystem's ability to grow trees. So tracking tree height over time can help us to assess the ecological health of a given area. Tree circumference can be used by foresters to calculate the approximate age of the tree. Both tree height and tree circumference can also help to measure biomass, which is the total mass of living material above ground measured across a particular area. While knowing an ecosystem's biomass is useful for many applications, such as farming, logging, and wildlife management, another helpful unit of measure in an ecosystem is how much carbon it stores. Terrestrial ecosystems contain carbon in the form of plants, animals, soils, and microorganisms, which are bacteria and fungi. Of these, plants and soils are by far the largest reservoirs of stored carbon. Trees have the greatest ability to store large amounts of carbon through continued growth because wood is dense and trees can be large. One of the focus areas of NASA's Earth Science Research Program is how forests, other plants, and the ocean are absorbing carbon. Forests are one of the major carbon sinks, which are areas that absorb large amounts of carbon dioxide from the atmosphere, storing it for decades in trunks and roots. NASA uses field campaigns and sensors on satellites and the International Space Station to improve our understanding of how much carbon is being stored on land and how this could change as patterns of drought, fire, and forest ecosystems shift in a changing climate. For example, NASA has launched satellites such as the Ice, Cloud, and Land Elevation Satellite 2, also known as ICESat-2, as well as instruments on the International Space Station, such as the Global Ecosystem Dynamics Investigation, also known as GEDI, which uses lasers to measure the height of objects on Earth's surface below them as they orbit our planet. Measuring this third dimension of forest structure can improve estimates of how much carbon is stored above ground in large forests. Ground sources of data are also needed to verify the measurements from satellites, and observations from citizen scientists like you can help fill in gaps in that data. You can gather tree heights from many more places than ICESat-2 scientists alone could measure on the ground. Scientists can also look for places where clusters of citizen scientist measurements overlap with ICESat-2's measurements and compare the two data sets. The GLOBE program is active in more than 120 countries around the world, and your data contributes to a database available to scientists and students like yourself to explore and investigate your own science questions. We are looking forward to seeing the data you submit to the GLOBE database related to trees and trees as land cover, and appreciate your contribution to helping us understand the importance of trees in the environment.